Hello friends, so we have a question on probability. We are given that there is a biased four-sided die. When we are saying it is a bias, that means the probability of getting any one number out of this four-sided die is not equal. The probability varies with the number. Is rolled and the result recorded. Let x be the result obtained when the die is rolled. The probability distribution for x is given in the following table where p and q are constants. So it is given that if we get the 1, the probability is p. If we get the 2, the probability is 0.3. If we get q 3, then the probability is q. And if we get 4, the probability is 0.1. So let us move on to the first part. In the first part, it is given that the expectation value is 2 and the value of p we have to show is 0.4 and 0.2. Now we know that all the possible outcomes are either 1, 2, 3 or 4. Hence, probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 must be equals to 1. Either of these four numbers will be there. So the probability of 1 is given in the question as p. Probability of 2 is given as 0.3. The probability of 3 is given as q. And the probability of 4 is given as 0.1. So it must be equals to 1. So what we get is p plus q equals to 1 minus 0.4, that is 0.6. So we have one equation in p and q. Now let us try to find how we proceed further. Now it is also given that the expectation value, what is ex? E of x is integration of infinity to minus infinity to infinity into x px dx. So it is basically the summation with the multiplication of the x. So here the value of ex is 2, which will be equals to 1 into probability of 1 plus 2 into probability of 2 plus 3 into probability of 3 plus 4 into probability of 4. So this is 2, 1 into p plus 2 into 0.3 plus 3 into q plus 4 into 0.1. So what we get is another equation in p and q. So the equation will be p plus 0.6 plus 3q plus 0.4 equals to 2. So the equation is p plus 3q equals to 2 minus 1 or equals to 1. So this is your second equation. Now let us subtract second equation. The first equation we get is 2q equals to 0.4 or q equals to 0.2. And if we put q equals to 0.2 in the first equation, we will get p equals to 0.4. So these are the values for p and q. Now let us try to identify the value of p for x greater than 2. Now for the value of p for x greater than 2, we have to identify the value of p for x greater than 2. So what are the possible values? So basically we have to find the value of when x can be 3 and also when x can be 4. There are two cases. X can either be 3 or 4. It has to be greater than 2. So the probability of getting 3 is, we see in the question, it is q, and q has been identified as 0.2. So this probability is 0.2. And the probability of getting 4 is 0.1. So let us add this 0.1. So the probability of x, basically the outcome being greater than 2 is 0.3. Now let us move on to the part C. So in the C part, we are given that Nikki plays a game with this 4-sided die. That is the biased 4-sided die. In the game, C is allowed a maximum of 5 tries. So C can have maximum of 5 rolls. Now her score is calculated by adding the result of each roll. Now she wins the game if her score is at least 10. Now we are given that after 3 rolls of the die, she has already scored 4. Now since outcome of each die is independent of the previous outcome, we have to find the probability that she wins the game. So she has already scored 4, and for winning the game she has to score 10. Now to score 10 she must score at least 6 in her last 2 rolls. So she has to score at least 6. So she might score 6, 7 or 8. The maximum possible outcome in 2 will be 8. So she will win the game if she scores a sum of 6 or 7 or 8 in her last 2 rolls. Now the die has these 4 outcomes. So to score 6, she can either score 2 then 4. She can either score 4 then 2 or 3 and 3. To get a 7, she can score 3 or 4 or 4 or 3. And to get an 8, there is only one possibility, that she must score 4 and 4. So what we will do is we will try to add up the probability of all these favorable possible outcomes. So in case of 2 and 4, what we will get is probability of 2 multiplied by probability of 4. In this case we will get probability of 4 multiplied by probability of 2. Here this will be probability of 3 multiplied by probability of 3. This will be probability of 3 multiplied by probability of 4. This will be probability of 4 multiplied by probability of 3. This will be probability of 4 multiplied by probability of 4. So let us try to solve this. What is the probability of 2? It is given in the question. Let us see. The probability of getting 2 is 0.3. So we get, this is the table we will be using, that is the probability of getting different outcomes. So probability of getting 2 is 0.3. So this will be 0.3. And from the same table, if you see, the probability of getting a 4 is 0.1. So we write here 0.1. Similarly, if you see, the probability of getting 4 is 0.1, and then getting probability of 2 is 0.3. Probability of getting a 3 is Q, and Q we had already identified is 0.2, and then again it is 0.2. This will be 0.0. This will be 0.03. This will be 0.04. Now the probability of getting 3 is 0.2 into 0.1. So this is 0.02. Now probability of 4 is 0.1. Probability of 3 we have already identified. This is Q. This is 0.2. So this is 0.02. And again the 0.4. Probability of getting 4 is 0.1. 0.1. So this is 0.01. So this is the probability. So 3 plus 3, 6. So 10. So this is 0.15. So 0.15 is the probability that the Nikki or she wins the game. So now let us move on to the next part. In the D and E part, let us try to read the question. In the D part, it is given that David has 2 pairs of unbiased 4-sided dice, a yellow pair and a red pair. And it is given that in the yellow dice, the outcomes are of a normal dice, which are 1, 2, 3 and 4, and when you roll it dice twice, the possible values of the sum of outcomes on both of the dice can be either 2, 3, 4, 5, 6, 7 and 8, and these are the probabilities of those outcomes. Now in the question it is also given that in the case of red die, it is not 1, 2, 3 and 4, it is different. What is the difference? It is given that in case of red die, the faces are 1, 2, 2 and 3, and the another die has 1, A and B. But at the same time, it is also given that although these are different, the outcome, the probability distribution for the sum obtained by rolling the red pair is same, exactly same as the distribution for the sum obtained by rolling the yellow pair. So what does that mean is the probability for getting a 3 or 4 as 5 or 6 or 7 as a sum is exactly same as that was in case of the yellow dice. So if that is true, the probability of getting 8 is 1 in case of yellow dice, and it should also be 1 in case of red dice. So there should only be one possibility that the sum should come out to be 8, and we already know B is greater than A, so the only possibility would be 3 plus B equals to 8, that means B equals to 5. Now to identify the value of A, we will try to see what are the possible values of the sample spaces. Now if these two dices are rolled, red dices are rolled, the possible outcomes could be 1 plus 1, which will be 2, which will get only for ones, and in our given sample space also, if we see, we are getting 2 only for ones. Now in case of 2, it is given that there are 2 possible outcomes. So are there any 2 possible outcomes for 2? So to get a 3, possible outcomes could be 2 plus 1 and 2 plus 1. There are 2 2's in the first dice. Now for getting a 4, there should be 3 outcomes for 4. Now if you see, there is one possible outcome of 3 plus 1, and another possible outcome could be 1 plus A. You could say that another possible outcome could be 2 plus A, but then it would be 2 plus A also, and it would come for 4 times if you see. So this is not a possible outcome for 4. It will get for 4 times, but in the given probabilities distribution, it should come only for 3 times. Now let us move to 5. For 5, what is given is that it should come for 4 times. So the possible values for 5 could be 2 plus A, 2 plus A, then again 2 plus A, and then 2 plus A. If you try to get another possible outcomes, like you may get 3 plus, in that case it would come out to be only 4. If you get 3 plus A as 5, then A will be 2, and there is no other possible value that you can get 5 for 4 times. Now similarly for 6, we have to get 6 for 3 times, and that 3 times can be 1 plus B as already possible, because B has already been found out as 5. Another possibility could be 3 plus A and 3 plus A. Similarly for 7, we have to get it for 2 times. So what could be the possible values? That is 2 plus B and 2 plus B, and for 8 we have already found 3 plus B. So if we solve this, we get A equals to 3. If we solve this, we again get A equals to 3, and if we solve this, we again get A equals to 3. So A equals to 3 satisfies all 3 cases here, and B has already been found as 5. So we can reject these cases confirmly and get our answer as A equals to 3 and B equals to 5. So that these are your solutions, and for more such questions do visit our website and register for detailed solutions and explanations. Thank you.